Okay, hello. So welcome to the second recording for MA1001 Dynamics Tutoring. Today we are going to talk about tutorial 4. Tutorial 4. So let me check. Yes, tutorial 4. And in tutorial 4, there's actually two very important concepts that we are doing. We are dealing with one of it is actually called the relative motion of particles. One is actually called the constraint motion of particles. So we will be talking about both concepts today. And actually, I'm not planning on wasting or spending too much time in the relative constraint method because it will also be covered subsequently in the next chapter in tutorial 4 and 5. Okay? Tutorial 4 and 5, I think so, if I'm not mistaken. So at that case, I will only put more emphasis in it. But today, I'm just going to give a very, very brief introduction of what relative velocity means. So, as for the constraint motion, I'll put more emphasis on it, but that will be in another video. That will be maybe next week's video, and I'll give more partial questions and answers so that you guys have a better outline understanding for it. So, as for your quiz, don't worry, just stick to what Professor Yap will give you and make sure you know how to answer all the questions, alright? So, let's go to the first part, tutorial 4. Yeah, first question actually asks, sorry, not the first question. So we're doing something known as point attached translating reference frame. So what is a point attached translating reference frame? So most importantly, let's not talk about concept, let's talk about equation first. So the only equation you will need for this part of the tutorial is just this. Velocity of A is equals to velocity of A with respect to B plus velocity of B. So this is actually a relative motion equation. So what it means is actually quite simple. What it's trying to say is just that, let's say I have two particles, particle A and particle B. So the velocity of particle A is equal to the velocity of particle A in B's perspective plus the velocity of B. And that's what it means. But there's a few constraints here. First of all, A and B must be, or not must be, sorry, I think this is the incorrect. Most importantly, what I want to know is that this so-called velocity of A with respect to B is actually a translating reference frame. Well, I'm not trying to say that VA slash B is a translating reference frame, but velocity A with respect to B means what is the velocity of A if you view from the reference of B, or if you view from the perspective of B. In other words, the reference frame is actually attached on B. And this reference frame is known as a translating reference frame. Point attached translating reference frame. That's what we talk about in the what is it called in the first tutorial. So the important thing you must understand is that this is a point attached translating reference frame. A point cannot rotate for itself. So the so-called attached reference frame XY axis is always facing one direction. That's called point attached translating reference frame. So that's the most important part here. So, but how do we get a real understanding and visualization of what does this whole equation mean? How does it manifest in terms of example? So, assuming I have these two situations, okay, I'll do this kind of examples in time. So let's assume that I have this what is it called? This grid. It is just basically a grid. This grid has nothing to do with the motion. This grid has nothing to do with the motion. The main purpose of this grid was to let you show how the motion converges. So let's say I have this so-called grid here. This is 1 meter, this is 1 meter, this is 1 meter. This is the secret. So, and definitely this length here is equals to square root 2 meter. And we draw the same grid here. Okay, just don't worry if you don't know what I'm doing. I'll explain later. So there's two grids. That's one grid here. This same thing is also 1 meter. This is 1 meter. This is actually 2 meters. Square root 2 meters. Yeah. We draw nicely. Right? Okay. Now, assuming I have one particle here. Right? There is particle A. Right? And I have another particle here. There is particle B. So, same thing for here. So this is just two different cases, but it's the same case. So the motion we view in this square here, the motion we view here is the absolute frame. In other words, we are viewing this as a stationary observer. What we will see if we were to stay stationary and A and B is moving. This is what we will see from the absolute frame. What is depicted here is, let's see, B's frame. In other words, what we will see in B's perspective. Okay? So I'm going to depict two motions, which are the same motion, but this part here, we are viewing from absolute motion. Means basically viewing from somebody who's stationary, which is us. This one depicts the motion, same motion that is viewed from B's perspective. In other words, the B straight. This straight attached on B is a point attached transmitting reference straight. So what will B see in other words? So let's say A is moving in this direction with a velocity of 2 meters per second. Velocity of A is a velocity of 2 meters per second directed 45 degrees. Along this line, because this is square now, 1 and 1, so it's 45 degrees, so 45 degrees. And this B, velocity of B, is directed in this direction, which is 1 meter per second, direction 45 plus 90 degrees, which is 125 degrees. Right? So, if I want you to calculate what is velocity of A with respect to B, velocity of what is velocity of B, A with respect to B. From that equation, we can straight away say it's equal to VA minus VB, right? And VA in this case is equal to 245. VB is equal to 145. Sorry, 125. Okay. Now, let's calculate out. Let's just get this part out. Let's do the whole derivation for this thing. So VA slash B is equals to VA minus VB, which is equals to 2 direction 45 minus 1 direction 135. Now, to combine what is it called polar vectors, the only thing we can do is just resolve it I and j directions and put them together. So this is basically 2 cos 45, 2 cos 45, cos 45 is 1 over 2. So we just square root 2 I plus square root 2 j. That's 2 cos 45. Means cos 45 sin 45 same thing. Minus, now, 1 cos 135 is actually negative 1 over 2, so it's negative 1 over 2 I plus 1 over 2 j, because sin 135 is actually equals to 1 over 2. Now, if we combine them together, we get something very interesting. We get some numbers. We get something called 1 over square root 2I plus, let me see, 3 over square root 2j. Right? It's always same. So if you combine together, you get this answer. And yeah, let me see now. Okay. Yes. So it is correct. This is correct. Supposed to be right. And oh, my bad. Sorry. I forgot my negative sign here. So this is supposed to be 3. This is supposed to be 1. Yeah, wonder I think there's something wrong. Okay, so when we have this thing, if you calculate out this thing, what is the magnitude of this thing? Basically, this equals to 9 over 4 plus 1 over 4 square root direction, arctangent, y over x, right? So it's actually 1 over 3. Right? And we know this is positive, it's less than 90 degrees because this both is positive numbers. Okay, it's in the first quadrant. Now, can somebody, so what is the arctangent 1 over 3? What is the angle arctangent 1 over 3? Can calculate out? Yeah, we have calculated, yes. Use that. Okay, so what is arctangent 1 over 3? Arctangent 1 over 3 is equals to 18.435 degrees. Arctangent 1 over 3 is 18.435 degrees. And to make things complete, 9 divided by 4 plus 1 divided by 4, square root the whole thing, you will get 1.1. Now it goes through the whole process. We don't want to make a very important point. Now what is this thing? This is a vector of V of A with respect to B. Now, this is B's frame. This is what is viewed by B. Now, when you are moving from B perspective, you think that you are not moving. So in other words, velocity of B with respect to B is 0, right? Because you think that it's not moving. And we calculated out velocity of A with respect to B is actually, if you do the calculation, do the math, is 18.435 degrees. Now, if you were to plot the direction of velocity of A with respect to B on this graph here, what you will get is actually a vector which points directly at B. You will get that velocity of A with respect to B is equals to 1.58 direction 18.435 degrees. And this 18.35 degrees is exactly this angle here, which pointed towards B. Meaning to say, in this exchange, A will collide with B. Makes sense, right? Let's not look at the A moving to B first. Let's look at this intuitively. A is moving at 2 times the speed of B. A travels 2 times the direction of B. So when they release, A and B will definitely collide at this point. Right? Can we say that A and B will collide at this point? So how would this manifest in terms of velocity of A with respect to B? When we do the calculation, we realize that the velocity of A with respect to B is actually a vector which is pointing directly towards B. In other words, in B perspective, B thinks it's not moving, but A actually travels in a velocity and direction that comes directly and hits towards him. This basically shows one of the conditions for 2 particles to collide. For 2 particles to collide, in one particle's perspective, the other particle must be traveling directly towards it from its initial position. And it thinks it is not moving. Right? Let me repeat that. For A and B to collide, B must think that A is moving directly towards him. In other words, velocity of A with respect to B must be directly towards him. And we have proved it. How do I prove that this theta is equal to 18.435? This theta is just equals to arctangent 1 over 3, right? Because this is a triangle, this is 1, this is 3. Then you can find that this theta is the same as this 18.435. So, in other words, I'm just trying to put a very important message across. I'm trying to put an important message across is that in all perspectives, things that occur must be true. In our perspective, okay, in our perspective, A and B collide at this point, right? It must the truth where A and B collides must also be true in B's perspective. But you must know that there's one condition when you are viewing from B perspective. When you are viewing from B perspective, you think that you are not moving, you think that B is not moving. So the only way A can collide with B in B perspective is that A is moving towards B. If you were to view the whole thing from A perspective, the only way B can collide with you is that B moving towards your direction. Same thing. Now you might think, but at the end of time, B is moving to this position. And if you think that B is not moving, it means that these two things are not the same situation because B moves, B does not move. So B is at the top of the triangle and B is not at the top of the triangle now. But the truth is that when we are dealing with particles like this, right, we are assuming that there is an empty room with no point of reference. So you cannot say that B is not moving. It just depends on which position you're looking for. If you are looking from an absolute frame, right, you will think that B is moving. If you are looking from B's frame, B will think that it's not moving. There is not absolute truth in terms of displacement, velocity, acceleration. There is absolute truth though on what has occurred, which in this case is a collision. So that's the main thing I want to bring across. What I want to bring across is that acceleration, velocity, and displacement is all relative. Depends on where you view from, who you view with, and what's going on. But events that occur like collision, breakage, or whatever must always be true no matter in which, what is it called, perspective. Okay? Now, we'll go to tutorials.